This is question 4 from the SACE Stage 2 Physics Course Companion from subtopic 3.4 Wave Particle Duality. Here we have light of wavelength 480 nanometers incident upon a metal surface which has a work function of 2.1 electron volts. First we need to calculate the maximum kinetic energy of the emitted electrons. To work out the maximum kinetic energy, we're using the relationship EK equals HF take W, where H is Planck's constant, F is the frequency of the light, and W is the work function. We have the wavelength, so we can determine the frequency. The work function needs to be in joules, but we can do that easily enough, just converting the 2.1 electron volts into joules. So first, let's calculate the frequency. We have the wave equation, which is V equals F lambda. Therefore, F equals V on lambda, which is 3 times 10 to the power of 8, all divided by 480 nanometers, so times 10 to the minus 9. Put that into our calculator, and we get 6.25 times 10 to the power of 14 hertz. Next thing we need to do is convert the 2.1 electron volts into joules. That's easy enough. To go from electron volts to joules, we just multiply by the charge of an electron. So here we have 2.1 electron volts goes to 2.1 times the charge of an electron, 1.6 times 10 to the power of minus 19. Put that into our calculator, and we get 3.36 times 10 to the power of minus 19 joules. And now it's just a matter of substituting both of these into the formula above. So finally we have EK equals Planck's constant, that's 6.63 times 10 to the power of minus 34. Multiplied by the frequency, 6.25 times 10 to the power of 14. Take away the work function, 3.36 times 10 to the power of minus 19. Put that into our calculator, and we should get 7.84. A few little tricky bits there. Put that into our calculator, we get 7.84 times 10 to the power of minus 20 joules. That's easy enough. Part B, we need to work out the maximum speed of these emitted electrons. So here we're just using our kinetic energy formula, is half mv squared. We can rearrange this to get V equals 2 times maximum energy over m all square rooted. And now we just substitute in the numbers that we've got. So 2 times 7.84 times 10 to the power of minus 20, all on the mass of an electron, which is 9.11 times 10 to the power of minus 31 kilograms, square root all of this, and we get 4.15 times 10 to the power of 5 meters per second. And that's it, that's not too bad. The hardest part's probably the rearranging of the kinetic energy formula, but the rest of it is pretty much just conversions and substitutions. Not really much else to it.